Welcome. Today we are going to continue looking at ionic compounds, and here we have what we call polyatomic ions or radicals, and here we have what we call monoatomic ions. Now the difference between these two types of ions is that now these ions that you are seeing here are just made of a single atom from a single element. For instance, we have sodium here. Sodium came from group 1. You see, sodium is in group 1. So sodium loses one electron in the outermost energy level to form a stable configuration. We have aluminium, which is in group 3. So it loses 3 electrons, it's a metal. We also have oxygen, which is a non-metal, which is in group 6 here. It gains 2 electrons to form a stable electronic configuration. Magnesium is in group 2, and chlorine is in group number 7. So as you can see, these ions here, they are just made up of a single, they are coming from a single atom. That's why we say they are called monoatomic ions. And we saw now in our previous video, we saw how these monoatomic ions form ionic compounds, and we show how to write the chemical formula. So today now we are going to put more emphasis now on polyatomic ions, of course with some metals which are monoatomic ions, and we see how they form ionic compounds. Now, polyatomic ions basically are ions that are made up of a group of atoms. As you can see now, we have carbon here and 3 oxygen atoms, and this group now here have got a charge. This charge is for the whole of this group of atoms. Now this is another polyatomic ion or a radical. It has got nitrogen and 3 atoms here, so there are 4. Poly means many, so we have many atoms here that have got a charge. This charge, negative charge 1, is for all these atoms here. The same for this hydroxide ion. You see, we also have an ammonium ion, we also have sulfate ion, and we also have others. These are just a few, but what we are going to see here will represent how we deal with all other. We have phosphate, we have sulfite, we have nitrate, and so on and so forth. Now, we want to see how these polyatomic ions form ionic. As you can see now, they are charged, so they obviously form ionic compounds. Now, our first ionic compound that we are going to look at will be magnesium sulfate. So, from this name, we expect that this ionic compound will be formed from a magnesium ion. We have said it is an ionic compound, and a sulfate ion. You see, magnesium ion has got a charge of +2, and this one has got a charge of -2. So this charge here is the one that tells us the combining capacity of these ions here. For instance now, or the valency of these ions here. So we have a magnesium here, let us see, and also now we have an SO3 like this. So the valency of magnesium is 2, while that of sulfate is 2. Now we are getting this from the oxidation states. So we have a 2 there and a 2 there now. Now these 2 tells us how many sulfates you combine with magnesium, and these 2 tells us how many magnesium you combine with sulfate. So we just cross multiply like this. And because 2 is an equal number, so the ratio, they are just going to cancel out. So it is going to remain as 1:1 like that. Now, this is the formula for magnesium sulfate. As you can see, the charges have balanced. We have a +2 and a -2. So those 2 charges are balancing out and they are cancelling out. So this is our formula for magnesium sulfate, as you have seen. Now let us look for another ionic compound. Now we are going to look at ammonium sulfate. Now, from that from this name, it is made from an ammonium ion and a sulfate ion. So an ammonium ion, this is an ammonium ion which has got a charge of a positive charge, and also now we have a sulfate ion which has got a charge of -2. So the valency for ammonium is 1. So if we click ammonia here and sulfate, so ammonia has got a valency of 1 like this, while this sulfate here has got a valency of 2. So now we cross. This means that ammonia will require only one sulfate. That is the combination capability. While now the ammonia will require two sulfate, where sulfate will require one ammonia, because we are going to cross multiply like this. So in case of this formula here, we don't write this one here because it is common sense. This is just 1. So when it is a 1, we don't just indicate the 1. But now here we have a 2, but this 2 is for this group here. So what we do is that we put a bracket. So these 2 now, we are going to put a bracket to show that we have 2 of this, like this, 2 of that. So the formula for our ammonium sulfate looks like something like that. Now this means that we have 2 of these. This means that we have 2 of that and 1 of that. Now if you look at these charges, we have a plus charge and a plus charge. Total is a 2 positive charge, which cancels out with these 2 negative charge. So this is what this formula now means. Now let us continue and look at our next compound. Now next compound will be magnesium nitrate. Now magnesium nitrate, it means that we have a magnesium ion like this and a nitrate ion like this. So the valency for magnesium, if you look at this oxidation state here, is a 2 plus. So the valency for magnesium will be 2. Where that one of a nitrate will be 1. Like this. So the formula now will be, you just go to multiply, 1 comes there and 2 here. Now, we say that we are not going to put 1 anywhere because common sense, this is just 1. Now, these 2 will represent, it's for the whole of this group. So what we do is that we replace that one by a bracket to show that now the 2 is for the whole of what? The whole of this. It means now you have 2 of nitrates and 1 magnesium there, like this. Two nitrate like this. Now, if you look at the negative charges, we have 2, 1, 2, and we have 2 plus charges. So these charges, they cancel out because they are equal, they are balancing. And that is the formula for magnesium nitrate. Now let us continue looking at these formulas. We have now sodium carbonate. Sodium carbonate means that we have a sodium ion here, like this, and a carbonate ion, which is something like this. Sodium has a positive charge of 1 and carbonate has a positive charge of 2 minus. So that means that the valency for sodium is 1, where that one of the carbonate is 2. So now what we do is just cross multiply. 2 comes here and 1 comes here. So we don't put 1. It's common sense that this is 1. So that is the formula for sodium carbonate. If we may expound that formula, it means that we have 2 of sodium, these ions. Now, if you look at these charges, we have 1 and 2 plus charges, and then we have 2 minus charges, so they cancel out. So a compound usually have a charge of 0 because of, now we have 2 negative and 2 plus, and the charges are cancelling out. So that is the formula for carbonate. Our next is aluminium hydroxide. This is an ionic compound that is made from aluminium. So it means we have an aluminium ion like that, and then a hydroxide ion like this. Now from this, the valency of aluminium, you see aluminium has a positive charge of +3, is 3. So we get our aluminium here and a valency of 3. Then we have a hydroxide ion which has got a charge of 1. So this means what? This means that we are going to cross multiply. At the end of the day, we are going to have a 3 here and a 1 here. So common sense says that we have 1, so we are not going to put this one here. Now, because this 3 stands for the whole of this hydroxide ion, we are going to put brackets like this. So we are going to put brackets, a 3 and like that. So the formula for aluminium hydroxide is that one, meaning that we have 3 of the hydroxide ions. And we can demonstrate this like this and like that. So this means that we have 1, 2, 3 negative charges, and we also have a 3 positive charges. So the charges are balancing and they cancel out. So our compound has a charge of 0. Now for our last molecule here, sodium hydroxide. Sodium hydroxide means that we have a sodium ion and a hydroxide ion. Now the sodium ion has got a positive charge of 1, and the hydroxide here has got a positive. The valency of sodium now of hydroxide is 1, and that of sodium is also 1 like this. So this, you cross multiply 1, that one is 1, and this is 1. So we don't just put 1. So the formula for sodium hydroxide is that one there. So we have many of these ionic compounds that are formed between metals and polyatomic ions. We have also compounds formed between monoatomic ions and so on and so forth. So generally, this is how we usually write the chemical formula for these compounds. Thank you very much for watching this video. We'll meet in the next video.